Hello everyone, today I am going to present on the topic of microstructural influence on bending and shear strength of aerospace material. This topic is very important in modern aircraft structural design because even if material composition is same, microstructure inside the material can completely change how that material behaves under bending load and shear load. So let us start step by step. Next is introduction. The definition of bending and shear strength. Bending is primarily due to movement applied to a beam-like structure, while shear acts parallel to the cross-sectional. Important in aerospace structure wings, fuselage and landing gear. In aerospace wings, fuselage, skin and landing gear continuously faces these loads. Understand where elastic region ends and plastic begins is very important because aircraft structure must work inside safe elastic limit. Therefore, objective of these studies is to link this basic mechanical behavior with microstructure feature. So let's see the next. Next is shear strength fundamental. The microstructure, how atoms are arranged within the metal or composite. For metal, one of the most important factor is gain stress. Here is the famous concept called Hall pitch effect. Smallest grains equals to more grain boundaries equals to more resistance to dislocation motion, higher strength. So finer grain material is strong. Heat treatment, forging, rolling is all processes are used to change grain size. For composite material, the microstructure means fiber distribution, resin bonding, voids and interlaminar quality. The crystal structure also affects stems, FCC metal, BCC metal and HCP metal. So next is microstructure and material behavior. Now the next is bending strength and microstructure. Flexury strength is calculated by the formula pi equal to my upon I, where refined grain yield strength goes up, so bending strength rises. Heat treatment also manipulate phases. For example, T sigma treatment is an aluminum created. For example, aluminium 7056T6 is used for high strength airframe parts, whereas titanium 64 is used where higher temperature capability is required. Now next, shear strengths and microstructure. Shear stress is calculated by tau equal to PQ upon IT. In metals, stress bands from during plastic deformation, fewer dislocation, mean higher resistance. In composite, shear is controlled by matrix and fiber matrix bonding. So microstructure of composite and interface chemistry strongly decides shear performance. Example, carbon fiber composites restrict shear delamination. Now next is application of mechanic and equilibrium. Now we connect to mechanical tools. We develop SFD and BMD for aircraft wings, spar under distributed lift load. Then combined shear stress and bending is visualized using Mohr circle. For Mohr circle, we find principal stresses, angles and plane where failure is most probable. This is why mechanical analysis and microstructure must be linked because critical plane is controlled by material. Next is analytical example. This slide shows the analytical producer constructed SFD and BMD then applied to bending and shear. Then use Mohr circle to combine the two stresses at that location. We interpreted where microstructure must be straightened. Example: wings root zone has maximum bending moment, so it needs best microstructure design. Next is aerospace case studies, real industry application, nickel superalloy turbine blade controlled participate restrict creep AILL fuselage panels, grain engineered for lightweight and fatter strength, composite wire space, carbon fiber orientation optimized for shear and bending load. Therefore, microstructure trailer is not just theory, it drives design decisions. Now conclusion. To conclude, the microstructure cross bending and shear stress grain refining, phase control, heat treatment and fiber orientation all directly changes mechanical property. So by understanding shear strengths behave like linked it with microstructure we select better materials, reduce weight and increase safety and fatigue lift in aircraft structure. Thank you so much. If any question is there, please comment below. Thank you.